Hello, Algebra 2 fans. Today we're covering the notes for 1-5, solving inequalities. Remember, on a number line, the values to the left of the 0 are the negative numbers, and the values to the right are the positive numbers. And we want to make sure we put those in the right order. What does a closed dot mean? On a number line, a closed dot means equal to. So that means you can actually equal the particular value where the dot is. And if it's an open dot, it means not equal to. It means I'm going to include everything right up to it, just not the actual number itself. In interval notation, that may or may not be a new notation for you. In interval notation, a bracket, remember a bracket looks like this, that means equal to. So a bracket is kind of like a closed dot. And the parenthesis means not equal to when we are doing our interval notation. I'm going to be kind of picky about the brackets and the parentheses. I don't want to see like that kind of thing, like is that half bracket, half parenthesis? What is it? Or the, I go straight and then I swirl it around or swirl it around. That's hard to tell. So if it's brackets, I want brackets. And if it's parenthesis, I want parentheses. All right? All right. So what if we have the inequality x is less than 7? First thing we want to do is we want to put 7 on our number line. 7 is a positive number, so it's to the right of 0. And I want the values that are less than 7. So what kind of numbers are less than 7? 0, -7, -10. Anything going this direction, those are the values that are less than 7. And then what about what happens at 7? Is it an open circle or a closed circle? Open dot or closed dot at the 7? Since it's not equal to, it's strictly less than, we will have an open circle at 7. Interval notation. Interval notation goes from left to right. So how far to the left do these values go? They go all the way to -infinity. Comma, how far to the right do they go? How far this way do they go? They stop here. I don't want to use a closed dot. That was terrible. They close here at the 7. That's where we end. And then what about our parentheses versus brackets? We can never, ever equal an infinity or -infinity. So those always get parentheses. And then since we cannot equal the 7, we need a parenthesis on the 7. Let's look at number 2. So number 2 says x is greater than or equal to -7. So we have a -7 that is to the, that is to the left of 0. And I want values that are greater than or equal to -7. Greater than would be these values going to the right. And then the equal to part gets me a closed dot at the -7. So for the interval notation, how far to the left can we go? The farthest left we can go is the -7. How far to the right do we go? Well, that arrow says we keep going all the way up to positive infinity. We don't have to write the positive for the positive infinity. Infinity is fine. We can never ever equal an infinity, so that will always get a parenthesis. And then in this case, we can equal the -7 because it was greater than or equal to. So then, since we can equal that, we need a bracket. Now, sometimes in Algebra 2, as you get more sophisticated in our mathematics, instead of using an open circle on the 7, sometimes they will actually put a parenthesis on the graph instead of the open circle. And sometimes instead of the closed dot, I knew that was going to take away everything. Instead of the, so here is our part, instead of the closed dot at the -7, they'll actually put a bracket there instead of the closed dot, which then you can see leads itself very well to our interval notation. Again, interval notation always goes from left to right. Parentheses for not equal to, brackets for equal to. Infinities and negative infinities will never be equaled. They always get parentheses. All right, so now we're going to solve some inequalities. They're the exact same rules for solving equations except for one rule change. The exception is, anybody know? Wait, say it louder. I didn't hear you. Very good. If you multiply or divide by a negative, then you have to flip the symbol around. So if it was originally greater than, it now flips around and becomes less than. If it was greater than, you're going to flip it around, now it's going to become less than. If it were greater than or equal to, you're going to flip it around, now it's less than or equal to. If it originally was less than or equal to, you're going to flip it around to greater than or equal to. And if it was strictly less than, you're going to flip it around, so now it's greater than. Again, only if you multiply or divide by a negative number. So let's look at number 1. Again, we're going to solve these just like we solve equations. So I need to get rid of the 7, I need to get rid of the 5. I'm going to do my reverse order of operations, and I'm going to subtract 7 from both sides. That gives me 5x, that gives me a negative 4. I'm still greater than. I did not multiply or divide by a negative. I subtracted 7. That doesn't count. All right, then what? Then I'm going to divide by 5. I'm going to divide by a positive 5. So I'm left with x is greater than negative 4/5. Now, just because I got a negative number doesn't mean I have to flip anything around either. I did not divide by a negative, so I don't have to flip anything. So where's negative 4/5? Negative 4/5 is less than 0. I want numbers that are greater than negative 4/5. So I want numbers that go to the right. And what happens at the 4/5? I'm not equal to. So I will either have an open circle there, or I could have a parenthesis if I want to use that. I'll take either. The interval notation, how far to the left can we go? We can go to 4/5. How far to the right can we go? We'll go all the way up to infinity. Parenthesis always on an infinity. And the 4/5, since I cannot equal it, I get a parenthesis there as well. Notice when we write this, we always want the variable on the left-hand side. If we do that, then the inequality symbol points the direction that we will shade on our number line. See how this is going, pointing to the right, and we shaded on our graph going to the right. I always do squiggles because sometimes if you just do a line right on top of the line, especially if you're writing on paper, it's hard to see. But with my colors, it works pretty well. All right, number 2. So number 2, we need to get the C's together. We've got C's on 2 sides. So I'm going to subtract 5C from both sides. Again, I'm subtracting, I'm not dividing or multiplying, so I don't have to spin anything around. This gives me a negative 3C plus 4 less than or equal to negative 8. Then what? Then I'm going to get rid of the 4, subtract 4 from both sides, negative 3C less than or equal to negative 12. Then what? Then I'm going to divide by negative 3. So when I divide by negative 3, those cancel. C, this gives me a 4. Now I have to spin my inequality around, and now I am greater than or equal to. So C is greater than or equal to positive 4. Graph my 4. 4 is positive, so it is to the right of 0. I want numbers that are larger than 4. These numbers here are larger than 4. What happens at the 4? Hence, I'm equal to. I have a closed dot at the 4, or you could do a bracket as well. Interval notation, how far to the left can we go? We can go to 4. How far to the right? Infinity. Infinity is always give parentheses, and in this case, since we were equal to, excuse me, I need a bracket on the 4. Let's try number 3. What I'm going to do first, I'm going to subtract 7 from both sides. I'm going to subtract 7, I get negative 4x greater than or equal to 16. Then I'm going to divide both sides by negative 4. I'm sorry, we're dividing both sides by what? By what? Yes, negative 4. So when I divide by that negative 4, I get x. Now I'm less than or equal to negative 4. Negative 4 is to the left of 0. I want the numbers that are less than that, so those are the ones that are going to the left. Equal to, so I need a bracket on the negative 4, or you could do a closed dot on the negative 4 as well. Integral notation, how far to the left can we go? Negative infinity. How far to the right? Negative 4, and the negative 4 gets a bracket. Questions? No one has any questions. I must be explaining it so very well. All right, number 4. What do you want to do? Distribute? Okay. So we'll distribute the 6. That gives us 6x minus 24 plus 2 less than negative 10. That gives us 6x minus 22 less than negative 10. Add 22 to both sides. That gives us 6x less than 12. Divide both sides by 6. Divide both sides by a positive 6. So no flipping necessary. We get x is less than 2. Here's my positive 2. I want less than, so that goes to the left. And it's not equal to, so I need an open circle at 2. The corresponding interval notation, parenthesis, negative infinity, comma, 2 with a parenthesis because we're not equal to. All right, why don't you guys pause the video and you try number 5 and see how you do. Okay, so hopefully you got here, v is less than or equal to 5. So we put 5 on our number line. We want the values that are less than it. So we go to the left, equal to, so we need a closed dot or again, a bracket. Interval notation, negative infinity to 5 with a bracket on the 5. And last but not least, number 6, we're going to multiply both sides by the negative 4 right away. So when we multiply both sides by the negative 4 right away, we get negative 32y. We have to flip our symbol around, negative 5y plus 9. Those negative 4's cancel. Then what? Then I want to add 5y to both sides. That gives us negative 27y less than 9. Then what? Then I'm going to divide both sides by what? What? Exactly. We're going to divide both sides by negative 27. So when we do that, we have to flip our symbol around, and that gives us a negative 1/3. So y is greater than negative 1/3. So in this case, we flip the symbol because of the negative 4, and then we flip the symbol back because of the negative 32. Here's negative 1/3. We want the numbers that are greater than negative 1/3, so we're going to the right. Strictly greater than, so we'll need an open circle. Our interval notation, parenthesis, negative 1/3, comma, infinity. And there we are, under 15 minutes, ladies and gentlemen. Yay me, and yay you. All right, try the homework, see how you do, and yeah, we'll check it out. Real quick though, I did want to mention on the homework, it doesn't say it in the directions, but I want to make sure you're practicing that interval notation. So after you graph the solution, also write it in interval notation. All right, thanks everybody. See ya, bye.